All right, so let's shift our focus to the actual moon. There's dark spots and light spots. The dark spots are called mares. And this is actually from back in the day when they thought that these were oceans on the moon. So it kind of comes from the oceanic term. Turns out these are actually lava flows, basalt, just like what our oceanic crust is made. And then you have the light-colored areas. These are called the highlands. These are elevated, lower density, so kind of like our continents. They're a lighter density, so they kind of float on top of the oceanic or the. So remember when I said that you couldn't see the other side, the far side of the moon, unless you get out into space? Here you go. Here's a picture of it. So unless you plan on going out into space, enjoy, because this is probably the only time you're going to see the other side of the moon. Lovely, isn't it? Basically just a bunch of craters. No mares, no highlands, just there. So we've talked about craters on Earth. Here's craters on the moon. Same thing. Meteoroid hits it and strikes the surface, creates a round hole. Also, some stuff explodes. You get stuff all over. It's called an ejecta blanket. And the heat from the impact goes down into it, creating a pulverized crust, leaving the crater a little bit larger than the actual size of the meteorite that hit it. Alright, so I said the craters would be a little bit bigger than the meteorite that hit it. That's kind of a fib. It's actually a good size bigger. They're usually about 10 times bigger than the actual meteorite that hit it, and 2 times as deep. Okay. Why is this? Because when it hits it, the heat from the impact actually pulverizes the material further down and across the way. So by pulverizing it, it can move a little bit easier and make the crater a little bit bigger, or bigger. Now on the moon, most craters date to about 4 billion years old. And then not a lot since then. So kind of really old all happened when everything was still young and developing. Alright, so here's pictures of some big ones, big craters, and then pictures of some little craters. This is, these guys are actually kind of microscopic. They're blown up so that you can see them. This is the type of meteorite that would have hit it, and then you can see the little crater that it actually. So a new definition for you, regolith. Regolith is actually on the moon. It's a layer of dust left by meteorite impacts, right? So a meteorite comes in, creates the crater, you get the ejecta. And now I said most of the craters are 3.9 billion years old. However, there are some craters that are tiny, right? You saw those in the previous slide. And the moon is still being hit by these little meteorites. They're actually called micrometeorites because they're so small. And so what this does is it kind of softens the features. Rather than having water or wind erode the surface and smooth everything out, you're actually having meteorites do that for you. And so the dust that it's causing is called regolith. And that's why if you look on the moon, or the picture of the moon here, you can see like tracks from the rovers and things because they've got the regolith, or the like dust, on the surface.